Hello students, this is Ms. Dalton and today's video is on function transformations. So our objective for this video is to analyze the effects on a graph when the parameters of the equation are changed. We're going to look at this in terms of vertical shifts, horizontal shifts, reflections, vertical stretches or compressions, horizontal stretches or compressions. So let's look at vertical shifts. So in this whole video, we're going to use this given graph right here. So I'll give you a tip. Just copy this graph down one time, and then every time we transform it, you could use a different color to show the different transformations, and that way you're not having to copy this graph over and over again. So when we look at a vertical shift, we're going to compare it to f of x plus 3. So f of x is just our original equation, our original function, our original graph. And if we add 3 to it on the end there, look at what happens to the graph. So the blue is the original and the red is after it has, after the f of x plus 3 has occurred. So you can see that it has been moved up 3 units. Now let's look at this same graph, but now let's look and see what happens to it if we subtract 2. So now let's look at it. So we've got the blue one, which is the original, the red is the new one, and so when f of x minus 2 happened, you can see that it has moved down 2. So in general, when you're looking at a graph and it has something being added to the end of it, so plus k, the graph of f of x has been shifted up if it's positive or down if it's minus, and then it's been moved up or down that many k units. So if we look at this, f of x plus 5, then that means it has been shifted up 5 units from the original f of x. And if we have f of x minus 8, f of x minus 8 has been shifted down 8 units from f of x. Okay, let's look at some horizontal shifts. So again, we're going to start with this original graph, which is the same one that we used before. And what happens to it if we have the f of x plus 3? And notice that the x plus 3 is in, it's in parentheses. So you can see what happens when x plus 3 is inside the parentheses. It has been shifted to the left 3 units. This will be important in just a minute. So notice that when it's inside the parentheses, it has been shifted to the left. Alright, so now let's look at our original function, and now let's compare it to the graph of f of x minus 1. And again, the x minus 1 is in parentheses. And so if we look at our red graph, you can see that it has been moved to the right 1 unit. Alright, so in general, a graph of f of x minus h, where the x minus h is in parentheses, if that h is positive, then it has been shifted to the left. If it is negative, then it has been shifted to the right. So I always say that when it's in parentheses, it goes... it lies to you. So it's the opposite of common sense. If it's minus, it moves to the right. If it's plus, it moves to the left. So if we look at this example, so f of x plus 5, because that is a plus, it has been shifted to the left 5 units. And f of x minus 8, because it is a minus, then it has been shifted 8 units to the right. Alright, so now we're going to look at what happens when we reflect it over the x-axis. So what does the original equation look like? So we've got our original graph of f of x, and now we're going to compare it to negative f of x. So you can see that it has been shifted over the x-axis. So this negative out front makes it reflect over the x-axis. So in general, a graph of minus f of x or negative f of x is the graph of f of x reflected over the x-axis. Alright, so now let's look at vertical stretch or compression. So here's our original graph again, and now we're going to compare it to what the graph would look like if we do 2 times f of x. 2 times f of x makes it stretch. It makes it get taller. Now, if we look at our original equation and we do 1/3 f of x, you can probably already guess what's going to happen. It makes it compress, or it gets smaller. Okay, so in general, if you have a number out in front of f of x, that is the graph of f of x that is vertically stretched or compressed. If that number is less than 1, then there is a compression. If it is greater than 1, then there is a stretch. So if we look at 1/2 f of x, that is going to be vertically compressed by a factor of 1/2 because it is smaller than 1. If we have 4 times f of x, that is vertically stretched by a factor of 4. Okay, horizontal stretch or compression. So think about when we talked about horizontal shifting, that was when we had numbers on the inside of our parentheses. So here's our original graph. Now we're going to do f of 3x. So notice that that 3 is on the inside of the x, and let's see what happens. So this time it gets compressed horizontally. So it's like you're putting your hands on each side of it, on the left hand side of it, and you're pushing in. It is going to compress it. Now, if we have f of 1/2 x, it is going to stretch it horizontally. So you can see that anytime it is in the parentheses, it's the opposite of common sense. Right now we have a small number, 1/2, but it actually stretches it. So it's the opposite. Normally on vertical stretch and compress, if it was a small number, it would shrink it, but because it's inside the parentheses, it does the opposite and it stretches it. All right, so here is in general what happens. If you have a graph, f of bx, and the b is less than 1, then there is a compression. Actually, that is wrong. Then I need to fix that. All right, there, that is fixed. Sorry about that. I fixed the ones at the bottom and I didn't fix that one. So you can see that that if it's less than 1, it is a stretch, and if it is greater than 1, it is a compression. So down here, if we have 1/2 x, f of 1/2 x, you can see that that 1/2 is inside the parentheses. It is a horizontal stretch. And f of 4x, because 4 is bigger than 1 and it is inside the parenthesis, it is a horizontal compression. Okay, so the big picture, what does this all look like all put together? Well, if you have a function f of x, and this is the following general transformations that can occur to that f of x. So we have all the way from, if you have a negative out front with a number a, f, and then anything on the inside b, and then x minus h, and then we have plus k on the outside. So if it's on the outside, that all happens vertically, but if it's on the inside, it all happens horizontally. So here we go. So h, that is a horizontal shift, left or right. If it is positive, then it moves to the left. Oops. Positive moves to the left, and if it moves to the right, it's a minus. And then horizontal stretch or compression, it's the opposite. So stretch is going to happen when b is less than 1, and compression is going to happen when b is greater than 1. A on the outside, that's a vertical stretch or compression, and it's just like what you would think. If it's greater than 1, then it's a stretch. If it's less than 1, it's a compression. If there's a negative out front, if it's in front of the function, then it is a reflection over the x-axis. Now, we didn't talk about what happens if the negative is inside the parentheses, but you'll look at it in class. When it's inside the parentheses, it actually reflects over the y-axis. And then the last thing is k, and that is a vertical shift up or down. All right, that ends this video. Please come to class ready and prepared, and make sure you answer those questions for me in the Google form.